Here we're asked to graph this system of linear inequalities. Okay, so let's look at that first inequality, and let's look at the boundary here. We're going to think of this as y equals x plus 0, and for the boundary on the second one, we'll look at it as y equals negative x plus 0. Okay, so let's graph up these boundaries. Okay, here's a Cartesian coordinate system. For the first inequality, let's look at the y-intercept here is 0. And the slope is 1, so we're going to rise 1 and run 1. Notice here I am using a solid line because the ordered pairs on the line are actually going to solve that inequality. And now let's run a test point, say 0, 1. Okay, when x is 0, y is 1, that certainly solves the inequality. So if I were to shade in all the ordered pairs, anything in this region will solve that first inequality. Okay, now let's focus on the second inequality, y is less than x. Again, 0, 0, the origin is the y-intercept. This time the slope is negative 1, so we'll rise negative 1 and run 1, down 1 over 1. But this time, notice, I'm going to use a dotted line, indicating that the ordered pairs on the actual line are not going to be part of the solution. Okay, so let's run a test point here, say 2, 0. When x is 2 and y is 0, does it solve that inequality? And you could see the answer is no, right? 0 is not less than negative 2. So when I shade in those values, anything in this region here should solve that second inequality. Okay, so to solve a system, you're actually looking for the intersection, okay? Where do the two regions intersect? Those are going to be the ordered pairs that solve both of the inequalities at the same time. So you could see this here is the region of intersection. And you can actually test a point to see. In this region, you can see what negative 3, 0 should work. And certainly negative 3 is less than 0. And when I plug in negative 3 here, I get a 3. And 3 is greater than 0. So try a couple points, convince yourself. Any ordered pair in this region here will solve both of those inequalities at the same time.